Welcome to Bitcoin Privacy with me, Noisy Mouse. In this video, we'll be looking at common input heuristic. Before we begin, let's go back to our favorite analogy with Alice going to the convenience store to buy her £3 meal deal. This time, Alice takes out two £2 coins, hand them over to the cashier, and the cashier gives £1 back to Alice as change. As a Bitcoin transaction, it will look something like this. On the input side, there will be two inputs of £2 each. And on the output side, £3 to the cashier, £1 back to Alice. Common input ownership heuristic assumes that all inputs of a given transaction are owned by the same owner. In this case, if we didn't know it was Alice who made the transaction, we could still apply the heuristic and assume the owner of the two £2 coins are from the same entity. Since we know those two £2 coins are from Alice, we could follow the coin's upstream history and learn more about where it came from and where it was spent previously. And it looks like Alice is a frequent visitor of this convenience store. And the two £2 coins from this transaction were changes left over for the same item from the previous transactions. Now, let's take a look at this particular transaction from OXT. Open up the transaction graph visualizer, select the transaction, and open up the transaction details panel. Here we have a basic spend transaction and a case of address reuse. We can start tracking the entity that made this transaction easily by following the output that matches with the input address. Even if the sender did not reuse address, we could apply script type heuristic to determine the sender by matching the address format. So the receiver in this case must be the address starting with 1. Let's follow the output and examine the next transaction. Once again, the address reuse behavior did not stop here. We just need to keep following the same address to obtain the transaction history of this entity. Notice that not only does the wallet software this entity uses reuse address, it also put the change output as the last output in the transaction, making it even easier to follow. We have finally arrived at a 2 input 2 output transaction. If we apply the common input ownership heuristic, we can safely assume that those two inputs are still the same entity we have been tracking since the beginning. And on the output side, we can see address reuse still happening. Coupled with the previous knowledge, we know for certain that the change output is always the last output of the transaction. We can say with a very high probability that these belongs to the sender and this is the receiver. We could keep following the change output to learn more about the entity's spending history down the line, but we are more interested in the source of funds for this entity. If we go back to the 2 input 2 output transaction, this time we could expand on the other input. Knowing that this input belongs to the entity we have been tracking, applying the heuristic that we know, we could unwind the transaction history backward until we reach the source of funds. And now I'll go up and down the transaction graph to uncover as much transaction history of this entity as possible, until we reach to a point where we could say this could be the source of funds for this entity. And we have arrived at an 8 inputs 2 outputs transaction. And these 8 inputs still belongs to the same entity. And if we examine the transaction of each input, we could see the transaction patterns are no longer the same. With different script type, no more address reuse. This suggests that these inputs are coming from a different entity/wallet software. This is the end of the video. I hope this was informative.